Hello, this is your first video for Math 112 College Algebra. This is going to be Unit 1. It's a much shorter unit than some of the other units. In this chapter or unit, we are specifically talking about solving quadratic equations and then maybe expanding on that a little bit. So you'll see that at the end. What you see here on the screen is just that. Solving quadratic equations is our objective here, including some applications there at the end. Slide this over so we can see the whole thing. There we go. So first of all, we need to know what a quadratic equation is. It is an equation that can be written of the form ax squared plus bx plus c equals 0. So the thing that you're looking for to make something a quadratic equation is this exponent of 2 being the highest exponent. We call that the degree of in this case, it's a polynomial. So that's what you're looking for here. We want the a to not be 0, meaning we have to have that x squared term there for it to be a quadratic equation. Couple of examples here. This first one isn't written in what we would call standard form, but you could rewrite it 5x squared minus 4x minus 6 equals 0 by subtracting 6 from both sides, and you do have standard form there. The second one, and just to clarify here, in this case, a is 5, b is -4, and c is equal to -6 in that standard form that you're looking at there. Here, this is a quadratic equation, but it's a quadratic equation where a is 8, b is 0, and c is -7. The b, the coefficient on x, is 0 because that term is missing. That still makes it a quadratic equation. It's when the a is 0 that it no longer is quadratic. That would be a linear equation if we had no x squared term on it. Okay, let's take a look here. Our goal for this section is to solve quadratic equations. And so that means we're going to get into some techniques here. The first, we're going to look at 4 different techniques. The first one is using factoring. So that's what you see here. And it's best to use when the equation, the quadratic itself, can be factored. This whole idea is based on the fact that if you multiply 2 numbers and you have 0, you get 0 from that product, then one of the 2 numbers has to be 0. There's no way to multiply any 2 non-zero numbers and get 0. Okay, if both of them are non-zero, you're not going to get 0 when you multiply them. That helps us by looking at something like this first example that's here, where we do have a product. We have x minus 3 times x plus 8, and that is equal to 0. We do have 2 things multiplied, x minus 3 and x plus 8. The product of those 2 is 0. That means one of those 2 has to equal 0. So we can set each of those factors equal to 0 and solve those. Adding 3 to both sides gives us x equals 3. Subtracting 8 from both sides here gives us x equals -8. And if you look back to the original equation, when x equals 3, if you plug that in, you have 0 times 11 is equal to 0. Same thing if you plug in the -8, you would get -11 times 0, which is equal to 0 when you plug those each in separately. So that's how we solve quadratic equations using factoring. This one was a nice example because it was already factored, right? You don't always have it in factored form like this one. Let's take a look at this. X squared minus 8 equals 2x. Well, first of all, this fact or property that we have up here, this guy right here, only works if you have it equal to 0. If this is not 0 right here, if that's something like 3, then we have no idea what A and B are. Because, let me give you an example. A times B equaling 3. Well, that doesn't mean A equals 3 or B equals 3. A could be 9 and B could be 1/3. And that is a true statement, right? We don't know exactly what those two numbers, A and B, are if this isn't 0. It only works with 0, okay? So don't try to set, in this case, A equal to 3 and B equal to 3. That doesn't work, okay? All right, so down here, we don't have it equal to 0. That means we need to get it equal to 0. We're going to subtract 2x from both sides. I'm going to put that in descending order, meaning I'm going to put that x term between the x squared and the 8 when I subtract 2x from both sides. Now this is not in factored form as it is, so we want to check and see if we can make it in factored form. We get, let's see, we need two things that multiply to give us -8 and add up to -2. All right. I think that will be, so sometimes people will put like a little thing over here. Two things that multiply to give us -8 and add up to 2 are going to be what? +4 and -2. So I need a +4 and an x -2 here. Okay. However you factor things, go ahead and do that. Factoring is a prerequisite for this course, so I expect you to know how to do that. Now we're in the same situation we were at above where we can set these factors equal to 0. X equals -4 and x equals 2. Okay? So we have those two solutions here. Notice above we had two solutions. One thing I should mention about this example above, is that really a quadratic? It certainly doesn't have the x squared as it is, but notice this quadratic equation formula up here is not in factored form. It's if it's multiplied out. If you were to multiply this out, you would get x squared. You would get plus 5x minus 24 equals 0 if you were to distribute that out. So that is a quadratic as it is. Okay? It was just written slightly differently than the standard form of a quadratic. All right, x equals 2, x equals -4 on that one. All right, let's take a look here. Second method for solving quadratic equations is using what we call the square root property. This is common when b equals 0, so that middle term, that x term, is 0 or is missing, or if you have a quantity squared. Here's what we have. If u squared is equal to a, then u is equal to plus or minus the square root of a. If you plug in either of those, the positive square root of a or the negative square root of a in place of u, you'll get a true statement. You'll get a equals a. So that's why those are the solutions of that. Let's take a look how we use that in a quadratic equation. This equation that we have here is a quadratic equation, x squared we have, right? It is missing the x term. So what we can do, this is a little different than how we treat it when we factor. When we want to factor, we always want it set equal to 0, meaning you put it in that standard form. This case, we're going to add the 8 over, and then we are going to use this property right here, because I do now have u squared equals a, where u is x and a is 8. Okay, so then I can square root both sides of this equation is what you'll sometimes hear people say. Square root, Don't forget the plus or minus when you do that. And you get x equals plus or minus the square root of 8. And of course, we want to simplify that root to 2 root 2, since 8 is 4 times 2. Okay, so now notice we have 2 solutions there as well. Every quadratic equation that we have seen thus far has had 2 solutions. That is interesting. We will talk about that in a little bit. Okay, this equation, this example that we have here, x plus 3 quantity squared equals 16. This is a quadratic equation because if I multiply that x plus 3 squared would be x plus 3 times x plus 3. And so when you distribute that out, you're going to get an x squared from here. And everything else will be smaller. It'll be plus 3x plus 9. So you're going to get x squared plus 6x plus 9. That is one approach to solving this equation. I would not solve this equation that way by multiplying it out. I'm just showing you that this is a quadratic equation. We have the x squared here that makes it quadratic. What I would do instead is exactly what we did on the last one, where we just had x. And I would square root both sides of this equation. That's going to give me x plus 3 is equal to plus or minus the square root of 16 is 4. I want to break this into 2 separate equations so that I can work with them a little bit. It's really easy to mess that up if you don't. So x equals 1, subtract 3 from both sides here, you get x equals negative 7. So we have these 2 solutions to this quadratic equation. Okay. All right, one more that looks similar, just slightly different than what we have seen. 6x squared minus 27 equals 0. You can isolate that x squared. Whatever the squared quantity is, you want to isolate that. On these first 2 examples, that was already isolated, meaning by itself. So the x squared minus 8, we just added the 8 to, and you had the x squared by itself. Here we had the quantity x plus 3 was already squared by itself. We're going to do the same thing here, so we're going to add 27 to both sides and divide by 6. That gives me, I want to simplify that because both of those are divisible by 3. So x squared equals 9/2. And now I'm going to use my square root property. Square root both sides of this, remembering our plus or minus, because you forget and lose solutions if you don't do that. So we have x equals, we can simplify that to 3 over the square root of 2. Of course, your plus or minus. You can leave your answer like that, x equals 3 over root 2, or x equals negative 3 over root 2, or you can rationalize that denominator. I'm not sure exactly what the system, your homework system you're using will require, so it's probably a good idea to rationalize that. When we say rationalize that denominator, it means get that irrational number out of the denominator. And we do that by multiplying by a fun form of 1, root 2 over root 2. That's just equal to 1, right? So you're multiplying by 1. It doesn't change the number itself, just what it looks like. That gives you 3 root 2 over 2, or negative 3 root 2 over 2. Okay? So that is using the square root property to solve quadratic equations. Again, that has a very specific use. As that stands, we wouldn't want to use that in some situations. What we're going to see for our next method for solving quadratic equations is a method called completing the square, where we're actually going to do a little bit of work and then use that square root property. I'm going to make a separate video for that just because this is getting long. And so I will, so look for that next video for the next two methods for solving quadratic equations.